So what I want to do here is look at the work done by the force field on an object moving in this helical shape. If I take away the vectors, you'll see it, and the object is moving along this helical shape. So it starts here at this blue dot here, and keep going, and it ends at this other blue dot there. So it makes two completions, two cycles, two periods around this helix. And the helix is given as this parametric set, 3 cosine s, s, and then 3 sine of s. So it basically lives moving along the y-axis. And then if I overlay the vector field on it, you see that it's going to affect it some way. We can zoom in a bit to see what these vectors look like. And then I made it so that, see how there's some curvature there? I made it so that you can make the vectors a little bigger to see what the motion looks like. It's not going to affect, the way I've done the calculations, it's not going to affect the work done. It's just to see it a little better how this thing is moving in just different viewpoints. Okay, and the way I did that was up here when I said functions that make the vectors, I said D is L dot the vectors themselves. So the vector components are P, Q, R. So you put your P, Q, and R here. That's P, Q, and R. And then when they're here defining X, Y, and Z, this tells you how many vectors you want. So it's going to be 11 times 11 times 11. So 1,331. You can change this to have less or more vectors. And then the function that make the vectors, notice that there's this L dot the vector field here. There's your vector field. And then L dotting with that will scale it differently, okay? And then this right here is essentially, this part right here is what I've shown in previous videos for vector fields. So anyway, we have our vector field and we have our object moving through it. And the question is find the work done by the force field F, which is Cxy, and move an particle from 3, 0, 0 to 3, 4 pi 0. Essentially, it's what's the effect of the force field on the object moving along that path. So we have a helix here that I showed before. Desmos 3D wants that helix in terms of S. It doesn't come out otherwise. And then we do work here. Work is F dot dr. And then we have our function here. Whenever you do the math behind that, you have to integrate this here. And so that's what I've done in the Desmos. It's down here, this part down here. I put my F here. You have to put your F here in terms of t, and then take the integral. And if you look, the value here of the work changes as we move through the object, through the vector field. Let me zoom out a bit, zoom in a bit. So as we move through the vector field itself, the object encounters different forces. So I would play around with this a bit if I were you. You can see kind of how as it moves through the field, let me make the vector a little bit smaller, it encounters different forces. And so as we go, the S value gets larger and smaller depending on where it's at in there, okay? So play around with this a bit, put in your own vectors, put in your own parameterization of a curve, and you have to put in this F here. You have to do that manually for this to work, okay?